final question, we are asked to find the tension in all of these cables represented here. The box is 50 kilograms. So we can start simply by breaking this up into different components, the vector components. So we want to solve in terms of force. So we'll start with FB, which is rather simple. It'll just be force B times I hat. And eventually later down the line we'll solve for all the individual forces, but for now we're just modeling them simply. FC is similar in that regard, except for the fact that it is going in this direction, which is negative to the y-axis, so it's negative FC. And FD is where it gets complicated, but not too complicated. We obviously have the thing we're trying to solve for. Now we want to represent this by the length, or sorry, rather the actual dimension listed here over the total length of this line. So for I hat it's going to be negative 2, because you can see here it's negative 2 in the x-axis, over square root 2 squared plus negative 2 squared, which obviously cancels out, plus 1 squared. And some simple math will tell you that that's square root 9. We know what that equals. And we can use that later down the line. So, from there, we want to follow that same pattern. It's 2 over 3 j hat, because it's 2 in the y direction, plus, oh boy, not sure what just happened there, plus 1/3 k hat, because it's 1 meter up in the air. Simple enough so far. Now, we've got those equations. Oops, I erased that, whatever. There's one final force that we want to find, and that is the force of the mass, which we know to be negative 50 times 9.8, which is equal to 490 newtons k hat. We've got one known. So, using the principle that this is in equilibrium, we know that the sum of the forces will be equal to 0. And we can break that up simply in their respective directions. So force of x would be modeled by FB up here, subtracting FD. So negative 2/3 FD, because that is what we solved previously as the x component of FD, and we apply that same logic to the rest of the formulas. Losing my voice. 2/3 FD minus FC is what we'll use for y. I should mention these are both equal to 0, because FC is in the negative direction, FD is in the positive. Yeah. And finally, forces in the z direction are equal to 1/3 FD minus 490 equals 0. So we've got equation 1, 2, and 3. We've got one equation where we can easily solve for the unknown. So, hang on a sec, let me write this a bit neater. From 3, we can find that FD is equal to 490 times 3, which is equal to 1470 newtons. And we can take this now and plug it into the other equation. So from equation 2, we can find that FC is equal to 2/3 FD equal to 2/3 1470, which ends up equaling 980 newtons. Excuse me. And we can do the same thing from 1. FB equals 2/3 FD. And we already solved for that up here, so we know that FB equals 980 newtons. And we've got our answer. We are done. Now if I quickly clear off the space and write this a bit neater, we'll see that we've got force of the mass is equal to negative 490 newtons. Rather, tension in the cable between A and the mass, and the tension in the cable between A and B will end up equaling, let me see here, 980 newtons. Tension in the cable between A and C is 980 newtons. And tension in cable AD is equal to 1470 newtons. And there is our answer.